Alright, we're going to pick up here with just another example. This is we want to graph 2 tan of x divided by 2. I recall our formula for that. I will label our amplitude and period off to the side, and then we'll do our process that we did last time that I put in the notes for. Okay, just to know some of our information, our a is going to be 2, and our period is, because it's a tangent function, is just pi over omega. Pi divided by 1/2 is just 2 pi. So an entire cycle is going to occur in 2 pi. Alright, let's first approach this with finding our asymptote. So we take our, remember, omega x minus phi, and set that equal to, because it's tangent, and tangent's undefined at negative pi halves and at pi halves. So we're going to separate and do it 2 times. For the first case, let's take our omega, in this case, is just 1/2. That's a known 1/2. Phi is just a 0 out here. So we're going to have omega x is equal to negative pi halves. And we're going to have omega x is equal to pi halves. This is to find my 2 asymptotes. And then here we just algebraically solve, multiply both sides by 2. And then the 2's cancel, 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 and we get x is equal to negative pi. That's one vertical asymptote. And then over here, multiply by 2 so that they cancel. So x is equal to pi. Those are our vertical asymptotes. So that's part A. Alright, and I'll actually just come over here and so that negative pi and at pi, we have vertical asymptotes. Alright, part B, we want to find midpoint. So in between, so to find the middle, if I have negative pi plus pi, that's 0. We want to divide it in half, divide by 2. It just puts us at 0. So midpoint between the 2 asymptotes at x equals 0. Let's come over here. Well, that's pretty easy. The middle of that, which these have been fairly easy ones the last 2 times, but that's the idea. You add the 2 asymptotes and divide by 2 to find the midpoint. And then I'll do part C on the next page. We're looking for 1/4 of the way and 3/4 of the way. So we're looking for 1/4 of the way and 3/4 of the way. So if I start it here, 1/4, half, 3/4 to the other asymptote. And I usually just like to start here because it's easier for me to think from 0 to pi and do half of that. So that's just going to be what? Pi halves. So just say 0 plus pi. That's to go from divide by 2 is just going to be pi halves. And then to go in the opposite direction, that's just going to be negative pi halves. Alright, the other thing we want to recall is to make sure we write our 2 tan x over 2. We can see that our a value is 2. So that means I'm going to come here and make that a 2. And this one's a negative 2. It's a tangent function, so it increases to the right. So I know by my parent graph and the fact that it's tangent that it increases to the right like that. And my 1/4 of the way, negative pi halves, negative 2. 3/4 of the way is pi halves 2. That's the ordered pair. And then from here, I'm just going to try to do the best I can to make a rough sketch of this. Whoa, not very good. Let's try that again. Okay. And then remember, we always have the fallback of making an XY table and a coordinate plane, plugging it in, and doing a lot of algebra extensive type stuff. Alright, and one example, let's do an example with cotangent x so you can see how that is a little bit different. Um, 3 cotangent omega x minus phi. We're gonna, if we did our A value is just 3. Our period would be pi over 2. So let's go ahead and start with our steps. Okay, so I jotted that information over there. So one cycle happens in pi over 2. Part A said find the asymptotes. Now we remember let me just jog back over here real quick. For cotangent, it's undefined at multiples of pi, such as 0 and pi. So when I set that equal to 0 and pi, that's why we're making that adjustment. So now I'm going to say our omega x minus phi, that's 2x and our phi is 0. So we have 2x is equal to 0. And my other asymptote would be 2x is equal to pi. And then we solve for x. So x is equal to 0 here. And x is equal to pi over 2. Those are going to be our vertical asymptotes. And we'll actually just jump over here to the next page and try to sketch that out. So between 0 and pi over 2. So this vertical asymptote is like right on right on 0, and this one is at pi over 2. Okay, that's the information we find in part A. For part B is to find the midpoint of that, which the middle between 0 and pi over 2 would be pi over 2 divided by 2. So let's do wrong way. 0 plus pi over 2 is equal to pi over 2, and we want to divide that by 2, which if I show all the algebra, dividing by 2 is the same as multiplying by 1/2, so that's just pi fourths is midpoint, so x equals pi fourths, and pi fourths is here. Okay, so that's part B. And then our next thing for part C is we want to find 3/4 of the way, 1/4 of the way, and 3/4 of the way. So we want to find what this value is going to be and what this value is going to be. So I'm just going to first of all do between 0 and pi fourths and half of that. So for part C, I'm going to say 0 plus pi fourths is equal to pi fourths, and I want to divide that by 2, which algebraically means we multiply by 1/2, so that's going to be what? Pi eighths. So this is pi eighths. And then between pi fourths and pi halves, where the last ones were easy, this one takes a little more algebra. Pi fourths and pi halves. To get a common denominator first would be leave this one pi fourths, make this one have a common denominator of a 4, so that would be, add the numerators, 3 pi fourths. Okay, now we got to divide that by 2. So when we added them together, we get 3 pi fourths, divide by 2, which means multiply by 1/2 is then going to give us 3 pi over 8. So this guy becomes 3 pi over 8. Lots of different ways you can do that, but this is just one method. The other thing is we're going to write our function down to remind ourselves what we're graphing here. 3 cotangent 2x. So our A value is positive 3 and negative 3. A fourth of the way at pi eighths. A fourth of the way between the two asymptotes is pi eighths. And our cotangent is going to be decreasing. So as I go from left to right, it decreases. So I know by my parent graph, a cotangent function looks like that. So whenever I go to graph this thing, at pi eighths, I'm going to be up here, and at 3 pi eighths, I'll be down here at negative 3. So I'm going to use the sketch of my 3 cotangent 2x right there. So real important that you remember cotangent as you go left to right, your function will be decreasing. And for tangent, when you go left to right, your function is increasing to be able to use this method. Like I said, as a fallback, we can always do this XY coordinate system for all of our functions, but I've showed you some different methods for each of these trig functions that can help you work through these and to get the graphs of these. So find what you're most comfortable with and use that method and go from there.